Welcome children. In this session we shall see how to prove midpoint theorem and also we shall solve some problems given in exercise 7.2 based on midpoint theorem. Now write down midpoint theorem. The line segment joining the midpoints of two sides of a triangle is parallel and equal to half of the third side. So first we have to draw the triangle. Take a triangle ABC and note the two midpoints of sides. Let it be E and F. Write down. Proof given. What's given? In triangle ABC, E and F are the two midpoints of side AB and AC respectively. Then to prove, what we have to prove? The line segment EF is parallel to third side BC and also line segment EF is equal to half of third side BC. So we have to prove these 2 points. Now make one construction. What's that construction? Let's see. Draw CD. Draw CD parallel to AB. Draw CD parallel to BC or AB or BA. Draw parallel and extend EF to join CD. So we have to extend EF also here. Take the scale and join this. Now we will see two triangles. One is triangle AEF and triangle CFD. Now we have to prove these two triangles are congruent. How can we prove this? We already know. Note down. Since E is the midpoint of AB, AE is equal to BE. Similarly, F is the midpoint of AC. So AF is equal to CF. These points are given. Now write down. Write proof. In triangle AEF, there are two triangles. We have to prove these two triangles are congruent. What are those triangles? Triangle AEF and triangle CDF. What are given? AF is equal to what? AF is equal to, already know, it is equal to CF. Reason is what? It is given because F is the midpoint of AC. That's why AF is equal to CF. And also angle, since these two sides are parallel, CD parallel to BA, therefore imagine EF. See, AB is parallel to CD and AC is the transversal. Then the two angles, alternate interior angles, these two angles should be equal, right? Now write down angle EAF is equal to angle, which angle? Angle DEF. DCF, angle DCF. Reason is what? Because CD is parallel to BA, alternate interior angles, alternate interior angles. Now here mark that angle. These two angles are equal. Similarly, can you say these two angles are equal? Angle EFA or angle AFE is equal to angle DFD, CFD or DFC, right? Why they are equal? Because these two angles are vertically opposite angles. So write down these two angles are equal. First mark here these two angles, mark here or double mark this as double mark. Therefore angle AFE is equal to angle D or CFD. Reason vertically opposite angles, vertically opposite angles. Therefore the two angles are equal. Now see here, side, this is angle, side, angle. Here also angle, side, again angle. Two angles and one common side. Here also two angles, one common side are correspondingly equal in two triangles. Therefore, how are they? These two triangles are congruent. Write down. Therefore, triangle. Which two triangles are congruent? AEF is congruent to triangle CDF. Reason ASA congruency rule. Now, therefore, can you say these two sides are equal? Here EF is equal to FD. Yes. Why? Corresponding parts of the congruent triangles are equal. Therefore, we can write EF is equal to FD and also or DF. EF is equal to FD or DF, and also AE. Can you say AE is equal to what? CD? Yes, write down. Therefore, EF, these are important. EF is equal to DF and also AE is equal to CD. Reason, corresponding parts of congruent triangles, CPCT. Now, look into the figure. AE is equal to what? BE. Why? Because E is the midpoint of AB. Therefore, AE is equal to BE. And now, we just proved AE is equal to what? CD. So, can you say BE is also equal to CD? Right. Now, write down. Therefore, BE is equal to CD. Reason is what? Because AE is equal to BE. That's why. Therefore, BE is equal to CD. And also, we know BE is parallel to CD, isn't it? Yes, because it is construction. CD is parallel to AB or BA, and also BE is also parallel to CD because half of AB is BE. That's why it is also parallel, right? From these two conditions, see, BE is equal, take this as equation number 1 and this as number 2. Now from 1 and 2, What type of quadrilateral BCDE is? Yes, correct. Because BE is equal to CD as well as BE is parallel to CD. Opposite sides are equal and parallel. Therefore, quadrilateral BCDE is a parallelogram. This is very important. Write down. Therefore, BCDE, that implies BCDE is a parallelogram. Now, can you say the property of parallelogram? Opposite sides are equal and parallel, right? Therefore, can you write BC is equal to ED and also BC is parallel to ED? Therefore, you can say ED is parallel to BC and also ED is equal to BC, because reason is what? Opposite sides of reason. Write down opposite sides of parallelogram. I will show you parallelogram in this way. Opposite sides of parallelogram. Now, you know EF is equal to FD, right? Just proved now. EF, see here, EF is equal to DF. Now, in place of ED, can you write twice EF, 2 times of EF? Yes, correct. Why? These two are equal. So, ED is equal to, I can write, and ED is equal to 2 times EF. Therefore, substitute now. BC is equal to what? BC is equal to, this is BC is equal to ED, no? ED is equal to 2 times EF. 2 times EF. Therefore, EF is equal to half of BC, right? Hence, we proved this midpoint theorem. Hence, we proved. Now, let us say converse of midpoint theorem. The line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That is, in a triangle ABC, if E is the midpoint of AB and it is parallel to, see, EF, let it be EF parallel to BC, and EF is equal to half of third side, that is half of BC. I will write here EF is parallel to BC, and then it also says that EF is equal to half of BC. Now, let us solve exercise problems based on midpoint theorem. ABCD is a quadrilateral in which P, Q, R and S are the midpoints of sides AB, BC, CD and DA respectively, and AC is the diagonal. Now show that SR is parallel to AC and SR is equal to half of AC. Similarly, PQ is equal to SR, then PQRS is a parallelogram. Now write down given. It's given in the question. In quadrilateral PQR ABCD, quadrilateral ABCD, AC is the diagonal Then P, Q, R and S are the midpoints of a side AB, BC, CD and AD respectively. Then to prove, what we have to prove, it's already given here. See, 1, 2, 3. These are to prove. Write down the same. SR parallel to AC and SR is equal to half of AC. Second one, PQ is equal to SR. Number 3, PQRS is a parallelogram. Now write down proof. Now look into the figure. In quadrilateral ABCD, AC is the diagonal. Now let us see in triangle ABC. Look into triangle ABC. P and Q are the midpoints of AB and BC. It's given. Therefore, according to midpoint theorem, third side AC is equal to what? Double of PQ, or PQ, we can say PQ is equal to half of AC and also PQ is parallel to AC, right? Similarly, we can say in this triangle also, according to midpoint theorem, SR is parallel to AC and also SR is equal to half of AC, right? In triangle ABC, according to midpoint theorem, AC is parallel to what? PQ and also PQ is equal to half of AC. Take this as equation number 1. Similarly, in triangle ACD, SR is equal to what? SR is equal to similarly in triangle ACD, according to midpoint theorem, SR is parallel to, or AC is parallel to SR and SR is equal to what? Half of AC. Half of AC. Take this as equation number 2. From 1 and 2, what do you conclude? From equation number 1 and equation number 2, we can conclude AC is parallel to PQ as well as AC is parallel to SR. That implies what? PQ is parallel to SR, and also PQ is equal to, I will write here, PQ is equal to SR. Do you agree this? PQ is equal to SR. Therefore, we can say PQRS is a parallelogram. Hence, we proved. Write down. PQRS is a parallelogram. Reason is what? Opposite sides are equal and parallel. Opposite sides are equal and also parallel. Therefore, PQRS is a parallelogram. Hence, we proved. Next, let us move to one more question. Question number 2. ABCD is a rhombus. PQRS are the midpoints of sides AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rectangle. Now, draw the suitable figure. PABCD is a rhombus. Property of a rhombus is what? All sides are equal and diagonals bisect perpendicularly. Now, it's given that PQRS are the midpoints of sides AB, BC, CD and DA respectively. Now, we have to prove PQRS is a rectangle. Now, what are given? Given in rhombus ABCD, P, Q, R and S are the midpoints of side AB, BC, CD and AD or DA and DA. PQRS is a rectangle. Now, we need some constructions. Take your pencil and scale. Join diagonal AC. Construction should be in dotted line always. Join AC and also join PR. It's also in dotted line, and SQ. SQ. Right? Now, proof. In earlier problem, we proved that PQRS is a parallelogram. Similarly, we have to first prove PQRS is a parallelogram. In triangle ABC, P and Q are the midpoints of sides AB and BC. It's given. Therefore, from midpoint theorem, we can say PQ is parallel to AC and also PQ is equal to half of AC. Similarly, in triangle ACD, again apply midpoint theorem. Since S and R are the midpoints of AD and DC, then we can say SR is parallel to AC and also SR is equal to half of AC. Now write down one by one. PQ is equal to half of AC, and also PQ is parallel to AC. Call this as equation number 1. This is equation number 1. Similarly, in triangle ACD, SR is equal to half of AC, and also SR is parallel to AC. Both are, reason is what? Take this as equation number 2. Reason is midpoint theorem. By the application of midpoint theorem, now from equation number 1 and 2, from equation number 1 and equation number 2, we can say PQ is equal to SR, see here, SR and PQ both are same, and also PQ is parallel to SR. This implies what? PQRS is a parallelogram. This now ABCD, we know it is a rhombus. Half of AD is what? AS, and half of BC is BQ. Therefore, ABQS is a rectangle. We can say, write down. Therefore, ABQS is a rectangle. What is the property of rectangle? Opposite sides are equal. Therefore, AB is equal to SQ. Similarly, we can say in PBCR is also a rectangle, because R and P are the midpoints of AB and CD respectively. Therefore, it's also a rectangle. Therefore, what are equal? PR is equal to BC. Therefore, write down BC is equal to PR. Take this as equation number 3 and this as equation number 4. But we know AB is equal to what? BC, because ABCD is a rhombus. All sides are equal in rhombus. Take this as equation number 5 if you need. Then from equation numbers 3, this is equation number 3, 4 and equation number 5, we can conclude that, see, look into the equations. BC is equal to PR, AB is equal to BC and AB is equal to SQ implies what? SQ is equal to SR. SQ is equal to SR. Therefore, but what are they? SQ and SR are the diagonals of PQRS, but these are the equal diagonals of parallelogram parallelogram PQRS. That implies what? That implies PQRS is a rectangle. That implies PQRS RS is a rectangle. Hence we proved. Hence we proved. Now let us stop to solve the problems, and we shall see new chapter from part 2 in our next session. Thank you.